Welcome to this channel. My name is Luigi and I study electrical engineering. So today I'm going to share with you probabilistic analysis on modern distribution networks considering high penetration of distributed energy resources. So I'm just going to cover all these 3 points: the context, the gaps and solutions. I'm going to give you a brief introduction about how governments they are planning, they are devising, and they are also enacting energy plans, energy pathways in order to meet targets that comes for low reducing carbon emission to and also to optimize the existing capacity of the power system. So I'm going to focus on distribution networks. I'm going to talk about distributed energy resources just in general, some advantages and disadvantages that it has bringing for many countries, gaps. I'm going to talk about these challenges that distributed energy resources pose for operation and planning, and also control methods that has been already uh, taking place in many distribution networks, but also I'm going to talk about probabilistic analysis, how this is important because of these new technologies. Solutions, I'm going to give you some ideas and applications that has been already in many research papers, has been already applied in industries, but that is what's coming, and so I hope this can be useful for you and that you can enjoy this presentation. So it's gonna last just I'm gonna try to be precise on the content. So as you know, governments they are fostering low carbon technologies as a measure to balance between production. That's important because we are talking about electricity sector, we are talking about manufacturing, we are talking about transportation, and they want to balance. I'm using this elephant over here as an example. They want to balance between one thing that's growing always. The more the production, that means that the country is in a positive economic growth, and but this is creating a concern about the global warming. So this is a problem, a big problem. So governments are trying to balance between this and that reduction of uh, carbon emissions. So they are, because of this, the actual scenario it's becoming sort of green. So that's the first reason why these low carbon technologies, distributed energy resources, renewable energy are taking place. This rapid um, integration is taking is taking momentum in the industry. So okay, now I'm going to share with you these 3 websites that's very interesting, that you can use it for getting an idea, getting to know what is the pathway for energy in the future. So basically, if you look at one of these sites, you can you can use these calculators to estimate how in 2030, 2040, 2050 the scenario will be for renewable energy, for example. So just I'm going to tell you just that this what's happening now is that distributed energy resources, when we talk about photovoltaics, wind power, this is really taking place in many countries, and that's what we need to know more about. And and also because governments they want to meet the target of reducing carbon emissions. So this calculator will come in handy for you to explore more of this. And so, okay, transition. Yes, we are talking about transition between a passive distribution network and a active distribution network. We are talking about transition from the traditional distribution uh, to uh, to a system that is that comprises this low carbon technologies, and not only that, but this is new loadings like um, we're talking about electric vehicles, we are talking about energy storage, we are talking about demand response. And so, but in the other hand, also we are talking about how solar power, can affect the operation of the system, or wind power. So basically, the traditional distribution system just worked, as the power plants. They send the energy through the medium voltage into the low voltage, and that's how it worked. That's how it has been for a really long time. But now, because they distribute energy resources, and because governments are fostering the use of these technologies, and and that all of us, we are aware of the importance of reducing carbon emissions. So that's how it works now. It consists of wind power, solar power, and even in that's for medium voltage, and even for low voltage, we are seeing now in that many homes they are installing their photovoltaics. And so we're in just now general definition. What's distribution energy resources is, we can talk about between dispatchable and not dispatchable. For dispatchable is the ones that you can control the energy. We can mention energy storage, demand response, that is applicable in many distribution networks. In not dispatchable, we talk about those we can't control the generation. For example, wind power, because it depends on the wind, and solar power, because it depends on the solar irradiation. And so it brings benefits and has some drawbacks. The benefits, of course, as you know, it's the that it contributes positively to climate change. It has lows, reduces, of course, the uh, carbon emission. But when we talk about the system, we can also say that it has energy loss reduction, it has voltage supports, it has power quality and restoration, and and that's important. And so this is the system supports benefits, but the drawbacks are over voltage, overloading, line overcurrent, flow reversion. This last one is very important, because in the traditional distribution network it was from one direction, the power flow, but now, because of the introduction of distributed energy resources, it has flow reversion. It means that it works in both directions. And so the gaps, okay, that's great, that has benefits, it has some drawbacks, but what is the gaps? The gaps is that these technologies, especially the distributed generation that depends on weather conditions, it brings intermittency of generation. And also because there are new loadings that we had no in the past, like electric vehicles. And so, and also how the client behaves, because it can controls now his energy production. So as you can see here, the weather is really unpredictable. I'm just going to show you a Friday 20 March, we're in 2020, and so we are just predicting the weather for tomorrow. And so as you can see here, there is a pretty much unclear scenario what's going to hold for tomorrow about the production of power generation for these distributed energy resources. As you can see here, there are raining, cloudy, more raining, cloudy, sunny. Even though it is in different cities, we can see that this really has an impact on the distribution network, energy demand, and energy supply. Basically, this is how it works. The production of energy, we can see that it's a pretty much common curve of energy demand. This one is for this yellow one is for the solar output, and the wind output over here. That's much even, as you can see. So this is real challenges, because of course we can't control this power output, but there exist, of course, control methods, and there are good management that's already taking place in distribution networks. But we need the use of probabilistic analysis. Why I'm saying this? Because in the past has been deterministic approach the most useful tool when it comes for operation, for planning, that the operators they had at hand, because that's how traditional distribution networks worked. And so, but now everything has changed because of the introduction of these new technologies. So this is how it has been for some time ago, and this is some um, research area that is taking place in many countries. How these control methods help to um, improve the operational constraints of the system, that it can keep in good uh, voltage range, that even the to meet the supply, the demand, but controlling in an optimizing way the supply of power production. So for example, the big problem has been voltage in many cases, and so they use these on-load tap chargers or capacitors, as you may know. And but also there are other proposals, that is conservation voltage reduction scheme. So you can uh, go through internet, you can research more about this, and but this is how has been going on for some time going, even today. DG power factor generation curtailment, this is used as a last resort, because the that's important, that also this renewable generation, of this distributed generation, that they can um, supply the energy, even though in an optimized way, because we want to balance as well profitability, and also the operational constraints, to reduce also risk of violating, some voltage, over voltage, for example. We don't want over voltage. We can accept some probability of over voltage. We don't want overloading. We can accept as well, but we need, these probabilistic tools for this. So for probabilistic analysis, of course, we have these parameters, these stochastic factors, that is a reality in the distribution networks. We have uncertainties in generation, we have uncertainties of new loading, we have uncertainties in elements and participants, we have uncertainties in markets, and also the statistical and probability information. We have the weather conditions, that even though we can estimate that tomorrow will be sunny, for sure we have no idea if it's gonna be sunny, maybe cloudy, maybe in the afternoon raining. So and this is the application, this is the importance of probabilistic analysis, how probabilistic analysis takes place, takes an important place for future. So we have here some applications that industry and many many modern or active distribution networks, they are looking for. They want to know, they want to better they want to better picture how the actual distribution network behaves. And so over voltage probability is important. Line overcurrent overloading probability is important, because the operator has to make decisions to accept or to turn off, to use this last resource, last resort, that's generation curtailment. And also using this probabilistic analysis, or we can assess, the system, and we can know that we have some sort of high probability over the voltage at bus 1, for example, and we want to reduce the risk of violating operational constraints. And so by optimizing the the system, the operation of the system, and knowing these probabilities, we can address these problems and accept low probabilities on technical issues. And so this is important. And hosting capacity of distributed resources based on probabilistic analysis. This is something that it's for now. Hosting capacity of photovoltaics, for example, are taking place in many cities like Australia and England, and also the United States. Even Brazil. These big countries, that have the solar irradiation, at higher degree than others. It has to be really important for them to of course, there already being studies considering hosting capacity, but I'm going to tell you that probabilistic analysis is important. That we need to consider this analysis. This is really complex. Of course, it's not that easy because there are many variables that will play. They have an important role that they play in this analysis. And finally, this probabilistic analysis, it's important because we can optimize the existing network distribution capacity. And so that's all for today. I hope you enjoyed this. If you have questions, just you can drop a line and you can comment, and so just give a like. And that's all for now. And anyway, I hope you can learn from these topics.